Hi guys, welcome to another episode of Learn with Sir Glenn. For today's topic, we're going to discuss arithmetic series, the use of s sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. On my previous video, we discussed about arithmetic series. Arithmetic series is the sum of terms of a finite arithmetic sequence, and it is denoted by s sub n. And we are also able to find its formula, which is s sub n is equal to n over 2 times a sub 1 plus a sub n. Although you have here the first term, which is 3, and the n, which is 16, because we are going to add 16 terms, we do not have the a sub n. So how are we going to solve for this kind of problem? So what we're going to do is to create a new formula for arithmetic series. So from our previous formula, s sub n is equal to n over 2 times a sub 1 plus a sub n. Notice that we have a sub n. In the arithmetic sequence, a sub n can be solved using the formula a sub n equals a sub 1 plus n minus 1 times d. So therefore, we can replace the a sub n on our s sub n formula with the a sub 1 plus n minus 1 times d, which will give us s sub n is equal to n over 2 times a sub 1 plus a sub 1 plus n minus 1 times d. So this is the formula for the a sub n, a sub 1 plus n minus 1 times d. So we use it to replace a sub n. So simplifying the formula, we will have s sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. So this will be our new formula for the arithmetic series. So now, how to use the formula? So let's say you have s sub n is equal to n over 2 times 2a sub 1 plus quantity n minus 1 times d. So suppose we want to solve the 3 plus 7 plus 11 plus 15 up to the 16th term. So the same with the previous formula, we have to identify first the variables on our formula. So first we have the n. So the n is the position of a sub n, or the number of terms that we're going to add. For this one, we have 16. So since we're going to add up to 16 terms, so n is equal to 16. Next, a sub 1, which is, we all know that it is the first term. On our example here, the first term is 3. Then we have the d, which is the common difference of arithmetic sequence. So for this one, our d is 4. You can actually obtain it by subtracting any consecutive terms. So 7 minus 3 is 4. That's why the common difference is 4. After finding all the values of our variables, we're going to use now our formula. S sub n is equal to n over 2 times 2a sub 1 plus quantity n minus 1 times d. So after this, we're going to replace all the variables with the values that we obtained. So n will become 16, a sub 1 will become 3, then d will become 4. So that's why our equation will become s sub 16 is equal to 16 over 2 times 2 times 3 plus quantity 16 minus 1 times 4. Then all we have to do now is to solve for this equation. So s sub 16 is equal to 16 over 2 times 6 plus 15 times 4. Applying the operation 2 times 3 and 16 minus 1. So simplifying it further, we will have s sub 16 is equal to 16 over 2 times 6 plus 60, which is 15 times 4. Then we will have s sub 16 is equal to 16 over 2 times 66. Then 8 times 66 is equal to 528. So the sum of 3 plus 7 plus 11 up to 16 term is 528. So that's why s sub 16 is 528. Okay, so let's try another example. Let's have 103 plus 100 plus 97 plus 94 up to 15th term. So what we're going to do is to first get the values of our variables. So we have the n. So this is the number of terms. So therefore, n is equal to 15. Then we have a sub 1, which is the first term. So that is 103. Then d, which is the common difference, is equal to negative 3. So since the terms are descending, so your common difference is a negative number. So now we can use the formula s sub n is equal to n over 2 times 2a sub 1 plus n minus 1 times d. So we replace the variables with the values that we obtain. We will have s sub 15 is equal to 15 over 2 times 2 times 103 plus quantity 15 minus 1 times negative 3. So n is 15, a sub 1 is 103, d is negative 3. So solving it further, you will have 15 over 2 times 206 plus 14 times negative 3. Then we will have s sub 15 is equal to 15 over 2 times 206 plus 14 times negative 3 is negative 42. So we will now have 15 over 2 times 164, which is 206 plus negative 42. So for this one, we're going to simplify 164 over 2. We're going to cancel 164 and 2, which will give us 15 times 82. So now we multiply these numbers, we will have s sub 15 is equal to 1,230. So the sum of terms of 103 plus 100 plus 97 up to 15th term is 1,230. Okay, so let's have our last example. So let's say you want to solve for this one. What is negative 5 plus negative 63 plus negative 51 plus and so on up to 12th term? So again, the same with what we did in our previous examples, we're going to use the formula s sub n is equal to n over 2 times 2a sub 1 plus quantity n minus 1 times d. And to use this, we have to get the values of our variables. So first, we have the n. So n is equal to 12 since we're going to add 12 terms of this arithmetic series. Then we will have the a sub 1, which is negative 75, which is the first term of the given arithmetic series. Next, we have to solve for the d, which is the common difference. For this one, the common difference is 12. So after finding the values of our variables, we can now replace the variables in our formula with the obtained values. Therefore, we will have s sub 12 equals 12 over 2, quantity 2 times negative 75 plus 12 minus 1 times d. So we replace n with 12, we replace a sub 1 with negative 75 and the common difference with 12. So simplifying this further, we will have 12 over 2 times negative 75 is negative 150 plus 12 minus 1 is 11 times 12. Then we will have 12 over 2 times negative 150 plus 11 times 12, 132. Then we will now have s sub 12 is equal to 12 over 2 times negative 50 plus 132 is negative 18. Simplifying it further, we will have s sub 12 equals 6 times negative 18. So multiplying the numbers, we will have s sub 12 is equal to negative 108. So therefore, the sum of negative 75 plus negative 63 plus negative 51 up to 12th term is negative 108. So thank you for watching and hope you have learned something from this video.